we are going to practice identifying the conjugate acid or conjugate base from an amphoteric substance. So remember, an amphoteric substance, that's a species that can either gain or lose a hydrogen, which means it can behave like a base if it gains a hydrogen, or behave like an acid if it loses a hydrogen. So the amphoteric species could do either. Let's take a look at hydrogen sulfate and HCO₃. Now, if it behaves like an acid, it is going to donate that hydrogen. So it reacts with water. These are both weak, so it goes into equilibrium. When it donates, loses that hydrogen, what's left over? SO4₂-. Now, take a look at the charges. When you donate, lose a hydrogen, you lose the positive, so the product is more negative. It goes from a -1 to that 2- right there. Likewise, if a species gains a hydrogen, it's going to get that positive proton, it becomes more positive. So this goes from a neutral to a 1+, H3O+. And just a little side note, you know, the quintessential, the #1 amphoteric species is water. Water acting as an acid or a base. So here, this is going to be our acid, base. This will become the conjugate base and the conjugate acid. If I look backwards, going in the reverse direction, the sulfate is going to accept the hydrogen, so it's acting like the base. Here, the hydronium is going to donate the hydrogen. And so it is going to go from the H3O to the H2O. That's your conjugate acid. Okay, now, same substance is hydrogen sulfate, but now it's going to be the base. So now it's going to accept that hydrogen. So it's going to accept the hydrogen. It goes from hydrogen sulfate to sulfuric acid. From 1 hydrogen to 2, it accepted that hydrogen. So this is the base, that will be your conjugate acid. The water acts as the acid, is going to donate the hydrogen, and it produces the hydroxide, our conjugate base. Okay, let's do 2 more. We're going to look at a dihydrogen phosphate. When it behaves like the acid, is going to donate. So it donates that hydrogen and produces from dihydrogen to just hydrogen phosphate. Look at the charge. Here it's 1-, now it's a 2- because it donated that hydrogen. That positive is gone. So this is going to be our acid. That's your base. The conjugate base and the conjugate acid. So when we go in the reverse, the hydrogen phosphate is going to accept a hydrogen and go from 1 hydrogen to 2. Your conjugate base, and then there's your conjugate acid for the hydronium. Okay, our last one. So the dihydrogen phosphate now is going to behave like the base, is going to accept the hydrogen. So you have 2 hydrogens, H2PO4- plus water. It accepts the hydrogen. So now 1 more hydrogen, it has H3PO4. It's phosphoric acid plus the hydroxide. So let's write this down. This is going to behave as the base. There's your acid. It produces the conjugate acid, and the acid produces that conjugate base. Very good. Well done. If you need more support, check out my end screen and you can get some more information on amphoteric species. Thank you for joining me. Like and subscribe, Old School Chemistry. Thanks so much. Bye.